Hey there. Here is what we're going to be talking about today, the periodic table of elements. If you do not have your periodic table of the elements, get it out right now. So click pause on the video and go get your copy of the periodic table because there's stuff in here that we have to learn how to use. Now, also, the second thing that you need is your notebook. So you need a place that is dedicated to take your notes. And so have that out. So if you do not have them, pause the video right now and go get them. Now, for the rest of you, I am just going to dive right in and start talking about stuff. So let me just shift what I'm looking at. And let's start a slideshow from the start. And here we go. How do I use the periodic table to get information about atoms? That is pretty much our learning target for the rest of the day. So now, let's find chlorine. So on your periodic table, chlorine is number 17, so it should be over there on the right side of the table. So find chlorine, and here are some things that you need to know, and you might have had some of these in the middle school, or some of your classes, I'm pretty sure, talked a little bit about the periodic table. But there are four basic things that you see in here. And the first thing is that number 17 at the top. That's called the atomic number. That's a really, 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 really important number. I'm going to get back to that in a second. Cl is the symbol. And you should understand that chemists do not like to waste pencil lead. And so they're going to find an abbreviation for everything possible. They're going to try and do things as simply as possible. And rather than writing out the word chlorine, they're just going to write Cl. There's the element name chlorine. That's just kind of an obvious thing. And then the last thing is called atomic mass. So the atomic mass for chlorine is 35.45. And just as an aside, it just says that if you have a mole of chlorine, you guys don't really know what a mole is, but I'm telling you that if you have a mole of chlorine, it'll have a mass of 35.45 grams. Now, let's look at some of the definitions. Hopefully you're listening to me, you're looking at what's on the screen and you're reading at the same time. And what you need to do when you take notes is you need to do all three of those things. You need to be reading what's on the screen, you need to be listening to me, and you need to be deciding as to what you need to write down. So, chemical symbol, there's your definition. If you're writing out every stinking word, please don't do that. When you take notes, you're writing notes, you're not copying. Anybody can copy. A person who takes good notes learns how to abbreviate things. So come up with your standard abbreviations for things. So anyways, chemical symbol is a shorthand way to write the name of an element. The atomic number is the number of protons in the nucleus. Whoa, there's an important thing. I'm going to get to that in more detail in a second. And every element has the same, or every atom of the same element has the same number of protons. So guess what? In the entire universe, yeah, let's think that way. Just think about the entire universe. Every atom of oxygen will have 8, count them, 8 protons. Yeah, every one. So every atom of the same element has the same number of protons. So here's why protons are really important. They define elements. So look at that last big bullet point. Protons define elements because here's what happens. The number of protons determines how many neutrons are needed to hold the nucleus together. Because guess what? Those protons are all positively charged and they're trying to get away from each other. And so the only way that you can get them in close proximity is to have something called the strong nuclear force, which neutrons provide, and that holds the nucleus together. So the proton number determines the number of neutrons, and then the number of protons determines the number of electrons needed to form a neutral atom. And that, the number of electrons, that sets up the orbital shape. And so the shapes of the orbitals and how many orbitals they are are determined by the number of electrons. So everything is focused around the importance of the proton. So I cannot emphasize the importance of the atomic number being the most important number in every cell of the periodic table. So now that you're watching my cursor, hopefully you see that I'm kind of making a circle around number 17. That's the most important thing in there, because that tells us the number of protons, and then it also tells us the number of electrons that we have in a neutral atom. All right, now let's talk about what atomic mass is. And this is going to be a squishy definition, and you may not totally understand it at this point, but that's okay. We're just going to run with it. So average mass is the average. Oh, average? Really? Why is it an average? Let's not worry about that. So it's the average mass for all naturally occurring atoms of an element, and it's always a decimal. If we were in class, I'd be pointing at my periodic table in the front of the room, but I can do that. Oh, shoot, I don't have my periodic table in the front of the room. So anyways, let's just talk about atomic mass, why it's an average. There are these things called isotopes, and we're going to talk about isotopes a little bit later in the week. And isotopes are just elements that have a differing number of neutrons. And when you change the number of neutrons, that's going to change the mass. And so you've got every chlorine will have 17 protons, but there are some atoms some atoms of chlorine that will have 18 neutrons, some have 19. And so there can be a varying number of neutrons in an atom, and those things are just called isotopes. And that's why it's an average. So you get a random sample of chlorine, the average mass will be 35.45. Mass number. Okay, that's not written anywhere in the periodic table, but here's how you get it. It's the total number of protons and neutrons. Oh, that makes sense. I remember from yesterday. Don't protons have a mass of 1 atomic mass unit? Don't neutrons also have a mass of 1 atomic mass unit? So the mass number is the total number of particles that have mass. And so it's the total number of protons and neutrons. And what you can do, notice where my cursor is going right now. So there's my atomic mass. It's 35.45. A simple way to get the mass number is round to the nearest whole number. So you can take an atomic mass, round it to the nearest whole number, and you will have the mass number for that element. So the mass number for chlorine, when you round it to the nearest whole number, is going to be 35.45. So now when you look at the bottom here to find mass number, there's 2 ways to go about it. And I want you to try and understand each one of these. Just realize mass number is the total number of protons and neutrons. And the second way that you can get the mass number is to round the atomic mass to the nearest whole number. All right. Now, let's have a look at the next slide. Here is what we need to know. This is the important information about the periodic table. So to find the protons, it's the atomic number. So the atomic number is defined by the number of protons. So chlorine with an atomic number of 17 will have 17 protons. Oxygen with an atomic number of 8 will have 8 protons. Magnesium with 12 for an atomic number. That means that every magnesium atom in the whole entire universe will have 12, count them, 12 protons. Okay, so I beat that dead horse. Now let's find the number of electrons. Guess what? In a neutral atom. Oh, a neutral atom. That means that there's the same number of positives, which are protons, as negatives, which are electrons. When you have something like chlorine, there needs to be the same number of negative charges as positive charges to balance things out, so you've got a neutral atom. So guess what? If there are 17 positive charges, there's going to be 17 negative charges in a neutral atom of chlorine. So the atomic number defines the number of protons, and it defines the number of neutrons. And now here is how we use the periodic table to get the mass number, or to get the number of neutrons. So take the, I've noticed how I've backed off a page. Take the atomic mass, round it to the nearest whole number. So 35.45 rounded to the nearest whole number is 35. And then what you do is you take that mass number and you subtract off the atomic number. So 35 minus 17 will be 18 neutrons. Now that last note that you see at the bottom of the page, that's just kind of a joke, because guess what? That's the math that you're doing. So really, this equation that I have right here, the neutrons is mass number minus atomic number. If I review here, oh my goodness, look at this. Mass number is the protons plus neutrons. I'll repeat that for emphasis. Mass number is the number of protons plus the number of neutrons. Oh, that means in our math here that neutrons equals protons plus neutrons, the mass number, minus protons. So if you simplify the equation, neutrons equal neutrons. Okay, we're doing some nonsense math there, aren't we? Okay, so now I'm going to escape out of here, and hopefully I've got this. This is what you need to work on. This is the atomic structure worksheet, and there's a link in Schoology somewhere for it. But all you have to do is use the 3 rules that you had back here, that the number of protons is the atomic number, the electrons is the atomic number, and then the number of neutrons is the mass number, and you subtract off the atomic number. So we're going to use these 3 rules to fill out the worksheet. So in the first case, let's go back here. Okay, so now you're going to need your best friend. You're going to need the periodic table to do this. So make sure that you've got that out. So using your periodic table, we're looking at the element helium. Okay, well, I want to type in here that helium is He, because I see that that's its symbol. By the way, when you're given the atomic number, it should be easy to find them on the periodic table, because all you have to do is follow the numbers. Hey, it's the periodic table is numerical. Isn't that amazing? So anyways, helium, there's a symbol. So the number of protons, well, the atomic number for helium is 2. And so you fill in that the number of protons is 2. And, oh, guess what? The number of protons and the number of electrons should be identical, because the atomic number, the thing that I've highlighted right there, that determines the number of protons. It determines the number of electrons, so I'm going to put a 2 in there. And so now the number of neutrons. Okay, number of neutrons. When I think back to the math rule, I go like this. Mass number minus atomic number. So I see to get the mass number for helium, it is 4, because you can you can take the information on the periodic table, round it to the nearest whole number. Oddly enough, it just turns out to be 4. So you take 4, subtract off 2, and you're going to get 2. All right, so now I've done the first one as an example, and I think that some of you might be noticing that, oh my goodness, 3 of these columns will be identical. Think about that for a second. That's true, isn't it? Think about it for a second. The atomic number determines the number of protons. It determines the number of electrons. So whatever you get here for atomic number, that will be the number of protons. That'll be the number of electrons. And then just the only other rule you have to know is the number of neutrons is equal to mass number. This column right here. Mass number. Subtract off the atomic number. All right, that's all I got for you. If you've got questions on anything, shoot me an email through Schoology, and I should be able to answer them. Good luck with this, and see you later. Bye.